All right, so a histogram is essentially a probability distribution in graphical form. Okay, it's just like a bar chart, pretty much, right? That's pretty much what it looks like. And so we're just going to take that probability distribution and graph it. Okay, so let's go ahead and look at example 4. All right, so here it says that a public housing authority in a certain community conducted a survey of 1,000 families and to determine the distribution of families by size. And we're given the results here in a table. The first question asks to find the probability distribution of the random variable x, okay? And where x denotes the number of persons in a randomly chosen family. Okay, so x is going to be our family size. That's our random variable. So we've got the random variable here in the first column, right? And apparently in this particular survey, the family size is ranged anywhere from 2 to 8. Okay, and this tells us the frequency with which that particular size occurred, right? When we had 1,000 families. So if you were to add up all of these, you should get 1,000, right? If you just add up all these numbers, and I haven't done it, but I'm going to guess that it's right. It says 1,000 families right here. So essentially 350 of those families had two family members. That was their family size. So essentially the probability is just going to be the relative frequency. We're just going to take 350 divided by 1,000. So we get 0.350. We're just going to move the decimal place 3 places to the left, right? Because we're dividing by 1,000. All right. So 200 of those 1,000 families surveyed had a family size of 3. So our probability is just going to be 0.2, right? 245 of those families had a family size of 4. So 245 out of 1,000 as a decimal is just 0.245. 125 families out of 1,000 had a family size of 5. So as a decimal, that becomes 0.125. 66 out of 1,000 were a family size of 6. So that's 0.066. 10 out of 1,000 had a family size of 11. So that's 0.010. And then finally, 4 out of 1,000 had a family size of 8, so 0.004. Okay, just dividing the frequency of occurrence by 1,000, so we get the relative frequency. That's just a probability distribution like we've done before. So now let's draw a histogram. Let's take that data and put it in a nice visual form. All right, so I'm going to, along the bottom here, this is going to be my family size. Family size. Okay, that's my random variable. So family size x, right? And I know that, based on the data that was gathered, I either had 2 or 3 or 4 or 5 or 6 or 7 or 8 people in the family. Okay, so I'm going to graph the random variable across the bottom. All right, and then I'm going to graph the probability. Now it's good to look at what the range is of these probabilities, right? It's going anywhere from 0.004, which is pretty small. Looks like the biggest one is 0.35. Okay, so it kind of looks like I've got, I could 1, 2, 3, 4. I really only need to go up to 0.4 ought to be sufficient, because 0.3. I need to go to 0.35. So let's just make each one of these tick marks here. Let's just make them 0.1, 0.2, 0.3, and 0.4. Okay, because I only need to go up to 0.4. I don't need to go all the way to 100% or 1, because the range of values just doesn't, I don't need that, right? I only need to go to 0.35. And just because I've got this nice grid here, 0.4 makes sense. Okay, so over on this axis, let me see if I can write sideways here. I've got the probability. These are going to be my probabilities. Probability. Okay, so I'm graphing probability on the vertical axis. Okay, and now I'm just going to show a bar for each probability. So the probability of 2 people in a family is 0.35, 35%. So I'm just going to draw a bar that goes up to 35%. Okay, so I'm just going to draw this little bar here that comes up. All right. For a family size of 3, it looks like it's 0.2. So I'm just going to graph the height of this bar at 0.2. For a family size of 4, looks like that's a little higher probability, 0.245. So that's just a little bit shy of 2.5 or 0.2, 0.25. So I'm just going to draw it like this. Okay, so there's my probability graphed as as a bar chart or a histogram. All right, so the probability of 5 people in the family would be 0.125. So it's about a quarter of the way up from between 1.1 and 0.2. So let's go right about there. Okay, so that would be my bar for 5. And then 6 is 0.06. Okay, so that's a little more than halfway up here. So I'll just put it about there. 7 is 0.01. So 1/10 of 1/10. So I got to go about a tenth of the way up there. Let's say that's about 1/10. And then 0.04. Okay, that's pretty small. So I'll just sometimes it's just not even easy to graph some of those small numbers given the scale. Okay, so that's basically my bar chart, right? I could put a little bottom on here if I wanted to. Ooh, it's hard for me to draw a straight line, but there's my histogram for the probability distribution. So it's just a graphical way of representing the probability distribution. All right, now we have a few questions here to answer. So find the probability that a family chosen at random from those surveyed has more than 5 members. Okay, so I want to calculate the probability that the random variable is greater than 5. Okay, not greater than or equal to, it says more than, so I guess it doesn't include 5. So what we're going to do is just add up the probabilities for 6, 7, and 8, right? So, sorry I can't get this, have both of them on here at the same time, but you can just look back at your table and read the values off. So 0.066 is the probability of having, is a probability of having 6, right? And then the probability of having 7 is 0.010. Probability of having 8 is 0.004. Add those all up. I got 0.080. All right. What's the probability that a family chosen at random has between 3 and 4 members inclusive? So we're including 3 and 4. So we want the probability that our random variable is between 3 and 4. So basically 3 or 4, right? So we're going to add up those probabilities. So the probability of 3 is 0.200. The probability of 4 is 0.245. So I add that up and I get 0.445. So about 44.5%. And then finally, what's the probability that a family has fewer than 4 members? So, actually, I have to read this carefully. It says 4 members or fewer, which seems to include 4. So I want x less than or equal to 4. So I'm going to add up the probabilities for 4 and 3 and 2. So 0.245, that's the probability for 4. 0.200, that's the probability for 3. And the probability of 2 was 0.350. Add that all up and get 0.795. So about 79.5% that you're going to have a family chosen at random will have fewer than 4 members. All right. So I guess that's the last example in this section. So take a look at the discussion questions. You might want to get a head start on them and start thinking about them. And I'll meet you in class.